Hey guys, coming at you with an extravagant video about math. This is going to be a three-part series for trigonometry. Trigonometry is an important discipline in math. It involves triangles and it is very prolific. It's used everywhere. Just for example, all the buildings and structures that you see laying around, they wouldn't be there. We wouldn't have a house, or at least the house that we live in, if it wasn't for trigonometry. It's a very applicable math. What we're going to do in this video is we'll define trigonometry, then we'll talk about the trigonomic ratios, and then we're going to do 6 examples. So, let's get started. Okay, first, the definition of trigonometry. It's a branch of mathematics dealing with the relations of the sides and angles of triangles. Now, some of you may be noticing that there's a circle here. I just want to point out that triangles and circles are cousins of each other. And often when we deal with trigonometry at a higher level, we're dealing with a triangle that is inscribed inside a circle. But that's well beyond the scope of what we're going to do here. Okay, let's take a look at SOHCAHTOA. So, there's 3 trigonometric relationships that we can use here. There is more than 3, but we're just going to discuss 3. We're going to discuss sine, cosine, and tangent. Sine, cosine, and tangent. And these are ratios. They're ratios that exist between the sides of a triangle. So, for example, if I go to the calculator and I type in something like sine 60, I get that number, which is in radical form, or I get a decimal. What that is the ratio that exists between the opposite and the hypotenuse. For cosine, I'll also use 60. You'll see you get 0.5. Well, that's the ratio that exists at 60 degrees between the adjacent and the hypotenuse. Then tangent at 60, and I'm just using 60 as a standard angle. We get square root of 3, or radical 3, and it's 1.73. And that's the ratio that exists at 60 degrees between the opposite and adjacent side. So in other words, what the calculator is doing to pull up these numbers, or these crazy irrational numbers that they're pulling up, is they're accessing the ratio between the 2 sides at a specific angle. That's the way it works. It's not like they're converting the angle of 60 degrees to that decimal. Okay? And we'll take a look at that when we do a couple of examples. So let's see what we got. Okay. First set of examples. So we're given a right triangle. Trigonometry can only be done in right triangles. And we're asked to find the missing side of a triangle. This is honestly the way trig is used the most, even in the real world. So let's take a look at how we're going to do this. Well, I'm going to label my triangle by drawing an arrow out from the angle. And that's going to give me my opposite side. Then the right angle, opposite the right angle, is the hypotenuse. And what's left is the adjacent side. From there, I'm given the hypotenuse and they want me to find the opposite side. Well, looking at SOHCAHTOA, which I'll write down here, so it's out of the way. That's the acronym for the 3 ratios. I have to pick one of these ratios. So sine, opposite, and hypotenuse is what fits here, because they gave me the hypotenuse and they want me to find the opposite side. So I am dealing with sine of theta. Theta is just a Greek letter for angles. And the opposite and the hypotenuse, right? So that's how we find, we divide these two to find this ratio with that angle. Okay, so now what I'm going to do is I'm going to plug in the information I have. So the angle is for theta, so I have sine 33 equals x over 14. Then I'm going to cross multiply and solve. So I put a 1 underneath sine 33. Now understand, sine 33 is a number. If you like, what some students like to do is they actually put it into a calculator and use the decimal 0.5446. Usually they go 4 decimals, and they use that decimal in place here, and then cross multiply. That's a good way to do it. So now I'm going to cross multiply here. And 1 times x is x. Then 14 times sine 33 is 14 times sine 33. Remembering that this is a decimal, that's the ratio that makes up the two sides. It's a constant thing. So now I can punch into the calculator 14 times sine 33. Just like that. And I got my answer. So x equals 7.62. Typically we go back to decimal points. Okay, that's that one. Next, so I need to find the hypotenuse this time, and I'm given this side. So let's label the triangle and see how that works out. Let me get the calculator out of the way. So I'm going to draw an arrow straight out. And this is the opposite leg. Then, this is the hypotenuse. And this is the adjacent leg. So this time, they gave me the adjacent leg, but they want me to find the hypotenuse. So I can't use the same ratio as I used here, because this one, they wanted me to find the opposite when they gave me the hypotenuse. So I take a look at my 3 trig ratios, and cosine calls for adjacent over hypotenuse. So cosine of theta uses adjacent over hypotenuse to find that ratio. So let's plug in the information that we have. Cosine 72 equals 6 over x. I'm going to put a 1 underneath here. Cross multiply and solve. So this time I have 1 times 6, which is 6. Then x times cosine 72 is x cosine 72. Now again, if you like, I just want to stop myself. If you like, you can punch cosine 72 into the calculator and get the decimal point and convert that to the decimal point. That might make more sense to you. The thing I'm going to warn you about is that the calculator is going back 9 digits. If you want to start writing out 9 digits all over your paper, you can do that. Most students go back 4. Well, that's a rounding situation now. So your answer may turn out different than what it turns out, or slightly different than what it turns out on a test or answer choices. So just be aware of that. It should still be close, though. You shouldn't be in the wrong ballpark if you're doing this right. Now, from here, I'm going to, back to the problem, I'm going to divide cosine 72 because x is not by itself. So I have cos 6 divided by cosine 72. So 6 divided by cosine 72 is going to give me my answer. And I'm going to plug that into the calculator as I see it there. Now, when using a calculator, I highly recommend you use a calculator like the one I'm using. There's a number of different makes for them, but the feature I'm using here that's really helpful is Math Print or Math Type. Calculators that have that allow us to put fractions in as we see them. They provide numbers and square roots, and that can come in handy. Definitely for later problems in trig when we start getting involved in squares and equilateral triangles. Okay, so that's that answer. I'm going to put an X here. Okay, next. So, this one, that gives me 14 there. I'm going to draw now a straight out. So that's my opposite. This is my hypotenuse. And this is adjacent. And now what I'm going to do is take a look at what they gave me. So they gave me the opposite leg, and they want me to find the adjacent. So I'm going to be using opposite and adjacent. I go to SOHCAHTOA, and I notice tangent uses that. So what I'm dealing with is tangent theta, then 14 over x. Now I'm going to plug in tangent 49 equals 14 over x. I'm going to put a 1 into here and cross multiply and solve. Now I like to cross multiply and solve. It relieves me of the duty of trying to memorize or remember when I am going to be dividing the trig functions or multiplying. It gives me more ability to pay attention to the problem itself by just doing this cross multiplication. I find that students often want to try to memorize when they're dividing or when they're multiplying, and I would consider that a bad habit. Because the problem when we try to memorize things is we often forget it quite quickly. Definitely if we don't need to access that memory for a while. And if you know how to cross multiply, that's something we do in math all the time. And doing that, it becomes easy to remember what you need to do. Okay, so that's finding a side. And that's the 3 trig ratios used. Now, remember, these are just examples that were generated. X can end up on either the bottom or the top, or the numerator or the denominator of the fraction. So, again, I repeat, cross-multiplying is really a helpful way to make sure you're setting up the trig ratio correctly each time. Okay. Let's take a look at the last 3 examples. These are quick. So, okay. Here it wants me to find the angle. Well, the calculator can work backwards and find the angle. So let's do it. So, this is opposite. This is the hypotenuse, and this is adjacent. I'm going to write my SOHCAHTOA down here again. A way to memorize that if you need to is write it on your paper every time you need to do trig. So I have written it 3 times if you just consider these slides. That alone is helping me remember the trig ratios. So this is hypotenuse, opposite, and adjacent. Okay, so now here, this is the hypotenuse, and this is adjacent. So what I'm going to do is use the cosine function. So I'm going to say cosine inverse 12 over 18. So the reason why I'm writing it like that is because that's the way the calculator does it. I'm sure there's methods to mathematically solve this, but I have a scientific calculator, and most of you will when you do this. So at that point, let's take advantage of the technology that's handed to us. So this is cosine 12 divided by 18. And there's my answer. Okay, 48. So the angle is 48.19. So now here, I accidentally made cosine twice. So what I'm going to do, I'm going to put that 5 over here. So we could use sine. So, watch. This is opposite. Try to write it out just so it's a little bit clearer for you guys. This is adjacent. And this is hypotenuse. Okay, opposite over hypotenuse, that's sine. So, I'm going to set that up as the inverse of sine. And that's 5 over 8. And so on this particular calculator, I press sine twice to get to that -1. Often you have to use the second or shift key to do it, to get to it. Okay, and I get 38.68. Often with angles, sometimes they round to the nearest whole number. Just be aware of that. You may see this answer choice as 39. And then lastly, this is opposite. This is the hypotenuse and adjacent's left. Labeling the triangle is key. Once I identify the sides I have, I could easily pick the trig ratios, definitely if they're in front of me, which one to use. So now, from here, this is opposite and adjacent, so I'm going to use tangent. So tangent, -1, and that's 9 over 23. I'm going to plug that in the calculator, pressing tangent twice, 9 divided by 23. And that's 21.37. Okay, guys, this is the video on trigonometry. It's part 1. Part 2 and 3 are going to follow. I hope you guys found this video helpful.